Dear all, in this video we are going to see the how to perform the timer programming for the 8051 microcontroller. So if before going to the timer programming, we need to understand that. So what are all the various signals that are associated with the port 3? So along these signals are multiplexed along with the port 3 signals. So if you notice this, we have the two timer signals in our 8051. So one is T0 and another one is T1. So the T0 was associated with pin number 14, and the T1 is connected with the is linked with pin number 15. So which is port 3.4 and port 3.5 respectively. And we do have the other functionalities, other features like handling the serial communications or handling the external interrupts and handling the external memory signals like read and write. So if you take a fundamental concept of the timer programming, basically in 8051 we have the two timers, or we can say it like that we have the two timer or counters. So they can be if it is a timer counters, either the timer can be used to generate the time delay, or the counters can be used to count the events that are happening outside the microcontroller. So delay generation means you can able to understand where exactly we need to make use of the delay. So through the software we can able to generate the delay. If it is for the counting of event, we can say the practical application like traffic light signal application and all. So basically there the down counting will be happens. That will be designed only through the timer counter concept of the microcontrollers. So if you take our 8051 microcontroller, we do have the two timers like timer 0 and timer 1. So both are 16-bit wide. So but our 8051 is a 8-bit architecture. These 16-bit timer can be accessed through the two separate registers like TH0 and TL0 for the timer 0, and TH1 and TL1 for the timer 1. So which TLX and THX represents the timer low byte and timer high byte. So if you take a timer 0 and a timer 1, so they can be accessed as a low byte and high byte. So the low byte register is called as a TL0 or a TL1, and the high byte register is called as a TH0 or TH1. So if you notice this one, so this is nothing but a timer 0 and this is nothing but a timer 1. So the lower order 8 bits are termed as a timer 0 lower order byte. So this is nothing but a timer 0 higher order byte. So this is nothing but a timer 1 lower order byte, and this is nothing but a timer 1 higher order byte. So these timer registers can be accessed like any other general purpose registers. So directly we can able to pass on the immediate value to the timer register. So here the hash represents it's an immediate value. So like any kind of a general purpose register, we are passing an immediate value to the timer register. So and again already some value will be loaded in the timer high 0 register that can be copied into any kind of general purpose register. So that is also possible in our 8051 programming. So if you take a 8051 timer, so it has got a in order to perform the timer operation, the important register is called as a timer mode. So which is used to determine our our timer is operating in which specific mode and what timer we have used for our application. So here we have the both the timer zeros and the timer 1 use the same register called a timer mode to set various timer operation modes. So here the T mode is a 8-bit register, timer mode is a 8-bit register. So the lower order 4 bit is used for the timer 0, and upper order 4 bits are used for the timer 1. So in this case, the lower order 2 bits are used to set the timer mode, and the higher order 2 bit is used to specify the operation, whether we are performing the counting operation, or whether we are performing the timer operation, or whether we are performing the hardware enabled timer, or whether we are enabling the software based timer. So both those things are mentioned by the upper order 2 bits, and lower order 2 bits of these of the timer 0 and timer 1 represents that is used to set the specific timer mode. So if you see this timer mode register, so gate generally if you take a gate, so if a gate in control when set, So the timer counter is enabled only when so if it is high, the timer counter will be enabled only when the INTX pin should be high, as well as the timer register must be in the high state. So if it is in the 0 state, so the timer will be enabled provided the INTX will be in the disabled state. So which means that if a gate pin is high, so we are trying to enable the hardware based timing operation. If it is 0, we are going to perform the software based operations. So here if you take a C/T bar, so if it is connected, if it is in the 0 state, we are making use of the timer for the delay generation purpose. If it is in the high state, we are making use of the counting of events. So as I told you already, so these M0 and M1 will be representing which specific timer mode we are going to select. So if it is in the 0 and 0, which is operating at a 13-bit timer mode, and again if it is 0 1, we are going to operate with the 16-bit timer mode, which is nothing but a mode 1, and if it is 1 0, it is operating in the mode 2, which is nothing but a 8-bit auto reload mode, and if it is 1 1, we are going to operate in a mode 3, which is nothing but a split timer mode. But for most of the practical applications, we'll be making use of either the mode 1 or mode 2. We'll be making use of either a 16-bit timer mode or a 8-bit auto reload mode. So in this 16-bit timer mode, so we will be loading the 16-bit value in the THX and the TLX register. So there is no prescaler is required in this 16-bit timer mode. Provided in the 8-bit auto reload mode, so 8-bit auto reload timer counter. So here we will be loading the 8-bit initial value into the THX register. So the THX holds a value. So after the THX reaches the maximum value, and again after the rollover takes place, the value which has been loaded in the THX will be copied into the TLX register. So each time whenever the timer overflow taken place, so it does not require, it's automatic loading of the initial value will be taken place from the THX to the TLX. So which is nothing but a 8-bit auto reload mode. We are going to this TLX will be loading only the 8-bit value. The same value will be copied into the TLX register. So this is nothing but a 8-bit auto reload mode. Whereas in the 16-bit timer mode, we are going to load the 16-bit timer value into the separate THX and TLX register. So here the X represents either it can be a timer 0 or a timer 1. So if your next thing is, so if you take a gate bit in the TMOD register, so the timer of a 8051 do starting or stopping either by means of a software or hardware control. So if you are using the software to start and stop the timer, so we will be making the gate as a 0, and if you are going to stop the timer by means of a hardware means, you are going to make the gate is equal to high. So you are going to make the gate is equal to 1. So the start and the stop of the timer are controlled by the way of software by timer start bits. So simply by making use of TR0 is equal to 1, you can able to enable the timer 0 register. And again TR1 is equal to 1 means you are starting the timer 1. And similarly CLR clear timer 0 means the timer 0 will be, the value of the timer 0 will be cleared, and again clear TR1 means the value of the timer 1 will be cleared, or we can say it like the timer will be stopped. So these instructions are used to start and stop the timers as long as the gate is equal to 0 in the TMOD register. So if you are making use of a set bit TR0 means what does it means? Which means that you are trying to enable the timer 0. If you are mentioning CLR TR0 means you are disabling the timer 0. And again similarly SETB TR1 means you are enabling the timer. So you are trying to start the timer. And again CLR TR1 means you are trying to disable the timer 1 register. So if you take a timer mode register, so generally in our programming we will be declaring the what specific mode that we are going to be operated. So here we have taken the author has given with respect to three different examples. One is we are initially the author has been loaded with the value 01 to the tmod register and 20 to the tmod register and 12 to the tmod register. So if you are loading the value 01 to it, so which means that timer 0 is timer 0 and mode 1 is selected. Mode 1 is nothing but a 16-bit timer mode. And again in the second case we have timer 1 mode 2 is selected. So therefore, so timer 1 which is going to be operating in the 8-bit auto reload mode. And again for the third example we have been loaded with the 1 and 2. So here the mode 2 of the timer 0 and mode 1 of the timer are selected. So both the timers are selected and timer 1 is operating in the mode 1 and timer 2 is operating in the mode 2. So if you take in order to find the timer clock frequency and its period for various 8051 based system. So for most of the practical applications, we'll be making use of the crystal frequency as 11.0592 megahertz. So that is when the C/T bar bit of the tmod is 0. So it means that we are trying to find the clock frequency here. So always for all the 8051 family microcontrollers, so the 1/12 of the crystal frequency attached to the 8051 will be giving us the 9 to 1.6 megahertz. So in order to attain the timer clock frequency, so that is 1 by 9 to 1.6 megahertz, that will be giving us 1.085 microseconds. So this is the time delay. This is the clock source for the time delay for the crystal frequency of the 8051 if it is connected with the 11.0592 megahertz. So if you take a C/T bar bit in the tmod register, the C/T bar bit in the tmod register decides the source of the clock for the timer. So if it is connected to 1, the timer is used as a counter and which is used to read the pulses from outside of the 8051. So if the counter counts up as the pulses are fed from the pins 14 and 15. So these pins are nothing but a T0 and a T1. So which has been discussed in the previous slide. So if you take if you see also it has been mentioned here. So the pin 14 represents the T0 and pin 15 represents the T1. So which is used to operate with respect to the timer counter 0 and timer counter 1. So for reading the pulses outside of the 8051. If the C/T bar is high. If the C/T bar is 0, so then we are going to operate for the delay generation. So and if you take a next important register is nothing but a timer control register, TCON register. So TCON register is a 8-bit register. So again this is also one of the bit addressable register. So if a gate is equal to 1, the start and stop of the timer are done externally through the pins P3.2 and P3.3 for timer 0 and timer 1 respectively. So if you take a timer control register, so you need to observe this carefully. The lower order 4 bits are used to store the TF and TR bits of both the timer 0 and timer 1, whereas the lower order 4 bits are set aside for controlling the interrupt bits. So these are for the basic timer operations we'll be making use of these 4 bits, and for the interrupt based timer operations we'll be making use of these 4 bits. So the lower order 4 bits are set aside for controlling the interrupt bits, and the upper order 4 bits are used to store the TF and TR bits of both timer 0 and timer 1. So if you want to perform the delay calculation, so here I have calculate the amount of time delay in the delay subroutine generated by the timer. So by assuming the crystal frequency is 11.0592 megahertz. So if you notice here, the timer works with the clock frequency 1/12 of the XL frequency attached to the 8051. So therefore, 11.0592 megahertz divided by 12, that will be giving us the 9 to 1.6 kilohertz as the timer frequency. So as a result, so each clock will be having as a period of 1 by 9 to 1.6 kilohertz, which is nothing but a 1.085 microseconds. So we can also say it like, so the timer 0 counts up each 1.085 microseconds, resulting in delay, which is nothing but a number of count value that has been loaded in the timer register. So that will be multiplied with 1.085 microseconds. So that will be giving us the time delay. So in order to if you want to precisely if you want to calculate that one, so here I have assumed the timer value as a FF F2H. So which is nothing, H represents its hexadecimal value. So the number of counts for the rollover is FFFF. The maximum value that can be loaded in the 16-bit timer register is FFFF minus FFF2H. So which is nothing but a 0DH. So which is nothing but a 13 in decimal. So if you generally if you take a, so it will start incrementing from FFF2, and again it will be incrementing till it reaches the maximum value FFFF for the upcounting. So in this case, what will happen? So it will require it is requiring 13 cycles from FFF2 to FFFH. So however, we need to have an extra clock that need to be considered. Why? Because once if it reaches the maximum value of FFFF, so far in the next cycle, it will be going for the 0000. So thereby it will be raising the timer overflow flag. So whenever the timer reaches the maximum value, so that the timer rollover occurs from FFFF2 to the value 0, and which will be raising the timer overflow flag. So thereby what I am trying to say is, so along with this 13, so we need to add one clock cycle additionally. So thereby, so it will become 14. So total number of clock cycles required is for our loaded count is 14. So that 14 into 1.085 microseconds for each clock period. So that will be resulting in 15.19 microseconds for, this is only for the half of the pulse. So thereby for the entire clock period, so which is nothing but a 2 times of the 15.19, that will be giving us the 30.38 microseconds as the time delay that has been generated by the timer. So this is how the delay calculation works with respect to the 8051. Provided if you take the delay produced by the 8051 by considering the mode 1 timer with the TH is equal to 20 and the TL is equal to 0F, and we are assuming that the crystal frequency attached is 11.0592 megahertz. So in this case, here we have been representing that we need to consider the 20F, which has been the timer, the initial value that has been loaded is obviously it is going to be in the hexadecimal form. So if you convert this value into the decimal, we are getting a 8207. So the maximum value that can be loaded in the timer register is nothing but a FFFF in terms of decimal, which can be represented as 65,536 minus 8207 for the loaded counter. So that will be multiplied with 1.085 microseconds. That will be giving us a 62.201 milliseconds is the delay that has been generated by the delay produced by the 8051 for the loaded count value by considering the 11.0592 megahertz crystal. So if you want to determine the frequency, so for frequency for the considered program, so let's see what is the program here. The following program generates a square wave on the pin port 1.5. So using by means of using timer 1, find the frequency, consider the hexadecimal is equal to 11.0592 megahertz. So here we are trying to load the value TL1 is loaded with the value 34 and TH1 is nothing but 12. So timer 1 has been loaded with it is nothing but a 16-bit timer mode. So the value loaded in the timer 1 is nothing but a 1234. So here the maximum value that can be loaded in the timer register is FFFF minus 1234 plus 1 need to be considered. Why? Because once if it reaches the maximum value, so timer rollover will be taken place. So we need to consider that cycle from FFFF to 0. So that cycle is considered here. So that has been yielding with the EDCCH. So which is nothing but in decimal, which is represented as 608076. So the 608076 into 1.085 microseconds will be giving us a 66.050 milliseconds. So for this is only for the half period, and for the total period, twice that of the 66.050 milliseconds will be giving us the 132.100 milliseconds. So this is for the total period. So if you want to, here our aim is to find out the frequency. So 1 by 132.100 milliseconds, that will be giving us a 7.57 hertz is the frequency that has been generated by the timer for the given program. So in this case, so next one is we are trying to So in this, we are going to see how does the toggling of operations with respect to the port one that has been handled using the timer mode one or 16-bit timer mode. So here we are making use of the timer 0 and 16-bit mode to generate the delay for the toggling operation. So in this case, here we are making use of the 0x55 and 0xAA. In between that, we are having the delay function. So upon execution of this function, so this this particular delay routine will be activated, will be executed. So the maximum value that can be loaded in the timer register, which is nothing but FF minus the initial value that is loaded in the timer register is nothing but at 3500. That has been given here. So that will be giving us a CAFFH. So if you are trying to represent in the decimal form, 51967 plus 1, which is nothing but a 51968. So this 51968 into so this is the nothing but a number of counts into 1.085 microseconds. That will be giving us a 56.384 milliseconds is the approximate delay that has been generated by this specific code. So if you take a next example, here we are making use of the same delay generation using the mode 1 16-bit timer mode. So here we are making use of the value 4BFD. So this 4BFD will be the maximum value FFFF minus 4BFD. That will be resulting in the 46082. So once the timer rollover occurs, so that will be up. So maximum value into to 0, we need to add a plus 1 to one value to it. So that is resulting as 46083. So this 46083 into 1.085, that will be giving us a 50 milliseconds as a delay for this specific code. And if you take a timer delay generation for the mode 2 8-bit auto reload mode is like so in this specific case we are trying to perform the toggling operation only on the pin port to 1.5 for every 250 milliseconds. So in order to ensure how this 250 millisecond has been achieved, so before that we need to the other section of the code will be having in the for loop we'll be mentioning the we'll be mentioning this 40 there. So the initial value that has been declared in this timer register is nothing but 23. Since the TH0, since it is an 8-bit auto reload mode, we are declaring only the TH0 here. So TH0 is equal to minus 23. So in 8051 we can able to declare the initial value in the terms of a negative sign also it is possible. So what will happen is like for the 8-bit register, the maximum value that can be loaded in the 8-bit register is FF. So in decimal it can be represented as a 256. So this 256 minus 23, that will be giving us a 233. So this 233 counts, actually it's a mistake here. So this 233 into 1.085, that will be giving us a 25 microseconds. So this 25 microseconds into 250 into 40, so that will be giving us a 250 milliseconds as a result here. So in this case, in this example, if you notice this, in both this example, you need to understand one thing commonly. So here we are not loading anything to the TL0. If you notice this, both the programs, we are not loading anything in the TL0. The meaning is like, so once if initially it will start from 233 to 256, it will be incremented. Once if it reaches the maximum value 256, in the next cycle it will be going to 0 and 0. So that particular transition we used to say it like a timer rollover. So once if the timer rollover taken place, a timer overflow flag will be raised high. So once if the timer overflow flag raised high, automatically the value which was loaded in the TH0, that will be copied into the TL0 register. So and again the same operation, the same procedure calculation will be taken place, and again so that will be producing the toggling in the pin number P1.5. And again if you notice this if you notice this program also, the same thing will be happening here. We are loading the minus 184 value in the TH1 register. So that will be resulting with that is resulting in the 184 milliseconds in the delay. So that will be used for the used to create a frequency on the pin 2500 hertz. So okay, so this is how the delay generation will be taken place with respect to the mode 2 8-bit auto reload mode programming. And again So there may be few confusions will be taken, will be handled in the 8-bit auto reload mode, that I will try to explain you in my keel while explaining the demo. I will try to explain that very precisely. So I hope so. If you like this video, I request you to kindly like, share and subscribe. Thank you.